In this tutorial, we're going to use PyGame to create a smooth moving controller. That is, a game which has speed so that a player character or an enemy will continue to move in a particular direction until that direction is changed. This is similar to what happens in Pac-Man. This is an example of Google's Pac-Man. Now, as I move, I either hit a wall and stop, or I keep going in a particular direction. So I'm going to press left on my Pac-Man now. And he moves until he hits the wall. Similarly, the ghosts move around until they are destroyed or attack Pac-Man. So we are going to set up a system in which speed is an important part of the movement. We're going to start off with something very similar to our setup from before, but we're going to include things like size for the size of our characters and an X speed and Y speed so that we can split movement into horizontal and vertical parts. So as with previous tutorials, I'm going to go to Replit. I'm going to go to Teams and Birkdale School. And then we are at stage 5, smooth control, stages 1 to 4. So project number 5 here. When the project loads up, we should see the README, and the markdown will appear over here with the preview switched on. So we can see that we're going to start off with our standard code that we've had so far. A few changes. We've included red as a color here. We've got size and we've got speed. And we're also introducing the clock to this game to help us in making a playable speed in our games. So if I go to main.py, you can see that most of this code is in place. I'm going to go here to my color section and I'm going to add red equals, and then I give a 3-color, a triplet in brackets. It's going to be 255 of red, all of the red, none of the green and none of the blue. I'm also going to just shrink this a little bit so the comments aren't causing such a problem. And I'm going to look at adding in, after my X and Y here, I'm going to add in size equals 10 and X speed, I'm putting these all in lowercase, is the same as Y speed, which start off at 0.0. Now notice all of these numbers so far have all been integers. They tend to do with shades and pixels and position and so on. We're using a real number, something that's got a decimal point in it here, because we want to be able to trickle along at a slow speed. We want it to smoothly ramp up instead of jumping in large chunks at a time. So we're using a real number that's got a decimal point there. And what we're also going to do, after we have declared our screen, we're going to add in something called clock. So that's our name for it. And it's going to be pygame.time.clock. Now notice that spelling of clock there has a capital C. And it's a function, so it needs to have brackets after it, otherwise it won't run the library code. So we have declared a timer that we can now use when we are working on our game. So I think we've covered everything that we need to in this stage 1, setting up our game with speed. So we'll move down and have a look at stage 2. So in stage 2, instead of what we had previously, which was the left key changing the X coordinate and the right key changing the X coordinate, we're not going to change the coordinates, we're going to change the speed at which the character is moving. Notice we also need to add in our constraint code. So that was to say, if we're trying to go left, we can only do it if the number will be positive. So, and x is greater than 0. Similarly, when we try to go up, we can only go up if we're not off the top of the screen. So that's and y greater than 0. And then you may remember that to stop us going off the right and bottom of the screen, we were looking at the height and width. So it would be and x is less than max width. But that would still allow us to go off because it draws from the top left corner of the block. So we also have to take away size from that. And similarly with down, we're going to say and max height, and y is less than max height minus size. I'll just be consistent there by nudging that up like that. Okay, now instead of changing the x coordinate directly, what we're going to do is we're going to say the x speed is going to be the x speed. Now let's think about this then. So if I'm pressing the left key, then I probably want to slow down or go fast in that direction. So it's going to be x speed minus, let's just say 1.0 at the moment. So all of these x's are changing to x speeds. And all the y's are changing to y speed. And 10 would be way too much to change speed by, so we're going to make it 1.0 minus 1.0 plus 1.0. And that should make it quite doable. So we could probably run this code now and see what's happening. And I'll just do that, make sure we haven't made any mistakes. There's no syntax errors. It's all good so far. I click in this window and I'm pressing my left, right, up and down keys, and of course nothing's happening. And the reason nothing's happening is because although I'm changing the speed, I don't have any code which is actually changing the position of the green block when I do that. So what I need to do is to add a new section to my code here. I've got this section which handles the user events. I've got this section here, and it does make a really good idea to just put a little comment in for each section. So this here is draw the screen. And I want to add in another section before that happens, and that is going to be the game logic section. Update positions, etc. etc. There would be things like check whether anything got destroyed or killed or eaten and so on. So what I now need to do here, if I go back to my README, have a look at the markdown, and I've put in all of my speed changing code there with the keys. But now I need to add a game logic section. And I'll just stretch this up a little bit so we can see all of that. Okay, so back in main, I want to change the x coordinates. Now this should happen all of the time. It should be just inside the while loop. It should probably be happening at the same level as doing screen things. So I'm going to go here, I'm going to tab in until I've matched up to where screen starts there. Might actually just be easier to outdent all of these by 1 and outdent this for loop by 1. Okay, so at the same level as screen, I'm going to make changes to the x. I'm going to say x equals x plus x speed. And of course, that's just one direction. That's across the screen. So I'm going to say y equals y plus y speed. If I can spell it. And actually, if I run this code, so what we should see here is if I press my up key, nothing's happening because I've got capture down in here. So I'm going to click in this window and I'm just going to give a little touch on that. And you see it very, very quickly went off the screen there. And then it came back. So it's very sensitive to changes in speed. And I could probably do some right and left. I've lost it now. So we need to be able to constrain it in the same way that we did previously with keeping something on the screen. So we can't just change the x and y speed and leave it to itself. We have to also cap it and prevent it from going off the screen. So what I'm going to say is, in the x direction, if x goes beyond max width, if it goes beyond the edge of the screen, then we want to say x equals max width. And similarly, if we've not got that, so elif x is less than 0, if it's trying to go off the other edge, then x equals 0. Now let's just check that that works for my x's. So I try moving, and I remember to click in this window. I try moving, yeah, it got stuck there. Oh, it's disappeared off. Same problem that we had before. I can't just deal with width. I also have to think about the size of the object. So I need to take into account that the object itself has a bit of girth to it when it's running. So move to the side, it sticks at the edge. Move this way, and it seems to have disappeared again. I think that was just to do with the size of the speed that it was using. Okay. Now, the other thing we want to do, if we get to the edge, we want to stop moving. So x speed equals 0. Because it's not enough just to stop you going to the edge of the screen, you also have to stop dead as well. Otherwise, you're trying to keep going all of the time. So let's see what that looks like. Click in this window, move to the edge of the screen and stop. Go the other way. That was rather fast. And it is still disappearing off. I think actually it's to do with the size of the screen that I'm showing here. So if I go up and change, yeah, these are 640 by 480. If I change that down to 400 and 300 so that we've got a tiny little screen to run in, then probably we can see the edges now. That's looking a bit better. Sticks at the edge, sticks at the edge, can still go off Y, so we need similar code in the Y direction. So I'm going to just scroll down here and do the same kind of thing for Y. So I've added in a bit of Y speed there, and I'm going to say if Y is greater than max height minus size, then Y equals max height minus size. And also Y speed equals 0. And if not, then elif Y is less than 0. It's elif then Y equals 0 and Y speed equals 0. And if I just quickly run that, then we should see that we are constrained and cannot